Okay, so how might you think you do this problem? Again, think about our advanced rules. You always think about the advanced rules first. You always think, okay, is this on my basic rules list? No. Is it a product? Is it a quotient? Friday's lecture, we'll see, oh, is it a composition, right? So I see some people saying quotient rule. I see some people saying product rule also. So how I have written, so it depends on how you write things. How you write a function very crucially affects what rules you're going to use to differentiate something, right? For instance, a product can always be written as a quotient, right? X over Y can always be written as xy to the -1. Of course, once you have something to the -1, you might now have a composition because, for instance, if I have, say, x over x squared plus 3, that's x times x squared plus 3 to the -1. So that's now a product, but also a composition. But I'm just emphasizing that a product can always be written as a quotient and a product and vice versa. So there's never a correct answer in how to write a function, but once you have written a function in one particular form, there is a correct answer in what you should do. So which comes first? Do I use product rule or do I use quotient rule first? So I'm going to put this as a poll, just kind of see if people are awake and thinking about this. So let's see. Product rule first, quotient rule first. None of the above, right? You think it's something else. Okay, so let's add that, save that. So let's see what we all think. Okay, about 9 more people, 7 more people. Can we get to 100% before the minute timer? 6 more people. 4 more people. 3. 1. Literally 1. Oh, no. Okay, so that's what we got. So we're pretty split, actually, right? 37% of the class thinks it's product rule first, and the other half thinks it's quotient rule first. So this is a quotient first, right? So what happens is the whole thing is a quotient, right? Now, when we do quotient rule, at some point in the advanced rule, I have to differentiate the numerator and I have to differentiate the denominator at some point in that rule, right? So when I differentiate the denominator, that looks like a product. So it's the whole thing is quotient rule, but within the quotient rule, you're going to use product rule, right? So quotient rule should come first here. So I'm going to give you just maybe 2 minutes to work on that. Hi, Margaret. Just saying hi. All right. So let's do that. Let's just say 2 minutes. Lashika, if you found some other way to do this, then do it that way, and you can reveal it after the 2 minutes are up. Also, I've linked the lecture notes in chat if you want to have them open on another tab to have that table at the start kind of on a different tab so you can keep on going back to it if you're not yet familiar with these rules. Okay, so what happened? What are we thinking? Nishika, you have a secret for us. Nishika, what is your secret?
I just rewrote it like how you can rewrite any function. If it's x to the -3, it's also 1 over x to the third. So I just rearranged it like that.
Okay, so in other words, you said you're rewriting this function. Okay, so let's rewrite it using negative exponents like you said. And then did you keep on going after that?
Can't you combine everything and it would be 7x to the -3 over 2? Or
Yeah, let's see. What is that? -3, that's -3.5, and 2 is -1.5, so -3/2. Okay, good. So actually, this was one big trick. So we're not supposed to use quotient rule. Now, using quotient rule is perfectly fine how I've written the function. That is the correct answer, right? I wrote the function as a quotient. But I did kind of give you a hint in what I was doing. I explained that how you write a function very, very crucially affects what rules you use. So if you can write a function in a different way that makes it easier on you to use the derivative rules, then you should do it that way. In this particular case, I can just combine everything. All of these are powers of x. So I can combine everything into actually just one big power of x. And that's actually a lot easier because now I can just use power rule. I don't need quotient rule. I don't need product rule. I don't need anything. I just need power rule. So in fact, I'm going to write as the solution, rewrite function in simpler form first. So again, using quotient rule with product rule was not wrong. And we will do an example where we actually do that. So don't worry about that. But the lesson I wanted to teach you here was you should always simplify the function first. Simplifying a function before taking a derivative is always a good idea because that means you'll probably have fewer rules to use, right? Because now I can just use power rule. So what is the derivative of 7x to the -3/2? Well, first of all, let's stress this. I cannot stress this enough. Whenever we have a coefficient on a function, coefficients really have no effect on the derivative. They just kind of come along for the ride, right? You should, first of all, you should definitely not be thinking of this as product rule. You should not be thinking of this as a product of two functions, 7 times x to the -3/2. Now that's not wrong, but it's definitely overkill, right? When we have a coefficient, we have a simpler rule where the coefficient just comes outside and I take the derivative of what is left over. The coefficient just comes along for the ride. So in other words, this is going to be 7 times the derivative of x to the -3/2. Right? You kind of ignore the coefficient, you just kind of just bring it along. And then x to the negative 3/2. So if I have x raised to a power, so I am using power rule, which I'll write here to remind you, it's on that list. Power rule says that the derivative of x raised to a constant has this form. The exponent comes down as a coefficient and then decreases by 1. So here I get the 7 is still coming along. And so the negative 3/2 comes down, right, as another coefficient. Negative 3/2, and then the exponent decreases by 1, x to the negative 5/2. So altogether we get negative 21 over 2, x to the negative 5/2. So that is the final answer here. Okay, any questions about that? Thoughts, questions, concerns, comments?
I have a question.
Yes, Harsh?
Like, could you have used quotient rule first, or that wouldn't have been possible?
No, it's possible. It's just overkill.
Oh.
The rules are consistent with each other. They never lead to a contradiction. So if I were to use quotient rule, right, I would have here, so first of all, the bottom gets squared, so let's just do that, right? And then I get f prime g minus fg prime. So f prime would be 14x and then times g minus fg prime. Now g prime needs product rule, and that's f prime g plus fg prime. So now that's 3x squared square root x plus x cubed times 1/2 x to the negative 1/2. So if you use product rule and quotient rule, you would have gotten this. I hope we can all agree that that's overkill for this function. Not only is it overkill, it also introduces a lot of opportunities to make a mistake, right? And if you need to do something else, like for instance, later on, we're gonna have applications where I need to set this equal to 0 or equal to 1 or something. If I need to now set this equal to 1 and try to solve for x, that's gonna be a lot more algebra now you have to do. Or you could have just done very little algebra at the very start and save yourself an entire headache, right? So the moral of the story is, do not just kind of rush into what you think the function is. Try to simplify it a little bit first. Cancel common factors, rewrite exponents, anything like that. So in fact, I'm just going to get rid of this because I don't even want to look at it.